Finally, some good news. This week, 2 vaccines have been shown to be effective against COVID-19. Science has stepped up again, and we should be very thankful for it. Welcome back, everyone. And finally, we've had some good news regarding COVID. How long have we waited for this? This week, we've heard that there are 2 vaccines that have been shown to be very effective against COVID-19. So, to date, this pandemic has claimed over 1.5 million lives at the time of recording this, with over 50 million people affected. Our lives have changed beyond recognition for many people as we've gone through this. But this week, 2 vaccines. How good is that news? One from Pfizer and BioNTech have produced vaccines that are 90% effective. And another vaccine by the company Moderna has also produced a vaccine that appears to have high efficacy as well. So this is 90% plus, and I don't think anyone expected it to be that effective. So the irony is before COVID came along, vaccine research was a bit of a backwater science. It wasn't considered a sexy science. COVID came along, obviously, and changed all that. And the resources that have been poured into this have been astounding. Never before has a vaccine been developed so quickly. To put that in perspective, it normally takes about 8 years from a vaccine to be developed to being on the market. And this has taken less than a year. It's incredible. It's almost unheard of. So the vaccines that are available at the moment by these 2 companies are the latest generation of vaccines. They're called RNA vaccines. So what exactly are these? One way of looking at it is that RNA can be described as the cousin of DNA. If it's introduced to our cells, can be read by our cells' machinery, internal machinery, and it can churn out amino acids. And those amino acids make proteins. And normally those proteins are made to repair cells or are involved in the biochemistry that keep us alive. But what the mRNA has been done in this case is been to encode proteins that are found in the virus. So when this RNA is introduced to your cells, the cell's machinery will read this and it will produce proteins that are found in the virus. And what this can do is that it can stimulate our own antibodies, our own defense mechanism to attack those proteins. So what that means in a nutshell is that our defense system, our immune system, is primed. So when we're exposed or infected to the virus, we're ready, and the virus is destroyed as soon as it attempts to infect our cells. So normally it takes 8 years from a vaccine from research level to be ready to be delivered to a population. And that's a huge amount of time. And rightly so, because normally you want, the primary concern is efficacy. Does it work? And also safety. If you're going to administer this to millions, if not billions of people, you want it to be safe. And that's why it can take so long. So what usually happens, there are different clinical phases that a vaccine has to pass, or any drug, a clinical drug trial has to pass before it can be given to a population. And they're very intricate. If you want to know a bit more about clinical phases or vaccine development, look at one of my previous videos. The point being is that usually each of these phases is completed one after the other. So phase 1, then phase 2, phase 3. But what's happened in this case is they've all been run in parallel, 1, 2, 3, and 4. That is it's a big gamble, because you're starting the second phase before you've got a positive outcome on the first phase. But that doesn't necessarily compromise the safety, because you have to wait for all those results to be in, which is what has just happened, before you can take the bigger leap and administer it to a larger cohort or amount of people. So this is unbelievable news. We've all had a very strange few years where it's almost felt that the quality or the emphasis on science and facts and critical thinking has declined over the past 4 or 5 years. I think this is a reminder of the power and the utility of science to solve problems. The whole world has been affected. Your life's been affected. All our lives have been affected. But yet science has stepped up again and produced vaccines that will protect us. And so that we can go and have those meals, spend time with our loved ones, go out, socialize, meet friends again. No other discipline in human endeavor could have achieved that. Another thing to consider is we're not quite there yet. Developing an effective vaccine is just the first part. The second part is it has to be produced at scale. We have to have billions of doses of this, and it has to be shown to be effective also on a wider scale when it's applied to millions of people. Another thing is that these vaccines are RNA-based vaccines. One trait of RNA is it has to be kept cold. I think the Pfizer vaccine has to be kept at -80 for long-term storage. So over the past 4 or 5 years, it almost seems like we've been besieged by this erosion of facts and how facts don't matter. But as I've said many times before, ultimately a fact is a fact. And this is where science and technology flourishes, because it's built on facts. The whole premise is to make a hypothesis, do your experiment, and if it works, then you move forward. And one of the great things about science is that it's progressive. It's very difficult to argue the result. If it can be repeated and then other people repeat that experiment, it becomes true. So one might argue, why do we actually need the truth? If there's been this erosion of truth over the past few years, it's because facts do matter. Let me give you a well-used analogy. Can you imagine if someone came along and said, 150 years ago, and said, I've got this amazing new flying machine. And you said, what, a machine that can fly? How did you build this? How did you do it? And this guy said, don't worry about it. Don't worry about it. Just get on. It will work. Just trust me. I'll push you off the cliff in this machine and you'll be fine. Would you get on that? No, you wouldn't. You would want, presumably, to know who built that, how safe it is, what were the calculations that were used, where were those people educated, did they have the knowledge to build this thing, what's the test flight data, what's the safety data. Presumably you want to know that before you got into a flying machine. So, and the only way you could get those answers is by doing experiments, doing the calculations, building the machine, doing the tests, and answering all those technical questions. Facts matter. So one thing I'm always very grateful for is that science, critical thinking, didn't have to happen. There are many cultures in the world as we evolved where it didn't happen. And luckily for us, science did flourish, and now it's spread around the world and it can give us results. So in summary, I for one am hugely relieved that we've had such good news against this fight against coronavirus, and over the coming months and maybe even a year we can really start to make an impact and get back to our lives. And we should be feel very fortunate that we live in the times that we do, and we've got the technology and the ability to do this, because it didn't have to happen. Thanks again for watching. If you do like these videos, press the subscribe button and watch out for the next video.